we have to figure out a way to derive this. Which means you as a student, you do whatever it takes to find the derivative of this. I will show you one way of doing that. If you get home tonight and you're working on a problem and you can't remember how to do this, then use what other things you know about deriving. You can use the chain rule on this. You're going to come up with the same answer if you use the chain rule. Okay, you can choose to expand this. You're going to come up with the same answer. I will show you how to use implicit differentiation with this. That may not always be the best option. And you've got to understand that this is very fluid. Like, the methods we use are very fluid. Sometimes one way works really well, and sometimes it doesn't. And maybe you start with one way, and it's like turning out super crazy, and you need to start over and try another way. Don't be afraid to do that either. Invest some time in what you're doing for the next 5 weeks of this class. Okay, so I'm getting rid of a square root because this is going to prevent me from using a whole bunch of chain rules that could make this really confusing. So I square both sides and I get d squared equals all of this outside of the square root. This now looks a little easier to derive than what we had up here. So I'm deriving this entire equation in terms of y. It doesn't change what we did the last time. The last time we had one variable that we were deriving in terms of. And over here we ended up with, I think, dA dx. So we had a derivative, and it just happened to be by itself already. We didn't have to worry about that. Okay? So we're deriving this whole equation in terms of y. And so over here, if I derive d squared in terms of y, we've learned implicit differentiation. We've learned that if we derive one variable in terms of another, we have to use this like chain rule concept. So the derivative of d squared in terms of y is 2d dd dy. Yes?
Okay. How did you get d dy? Like, did you actually like derive d dy like with the letters?
Yes. So let me go back to, I'm going to go back to like the middle of the last example where we were at with area and stuff. We had area equals 2400x minus 2x squared.
Right.
And we had to derive this equation because we were looking for maximum. So when I derived this, and maybe you guys didn't notice this and you didn't write it down, or maybe you did write it down and didn't know what it was, but I derived this entire equation in terms of x. So I did d dx and d dx. Okay? If I derive a in terms of x, that's just going to give me dA dx. And this is the derivative I'm looking for. So I did do the same thing on that one over there, on the first example we did, and then we just kind of skipped over to this and we derived this, and then we set this equal to 0. That's the same idea happening here. It's just that I don't have just a d, I have a d squared.
Can you show me what that would look like with the squared on the a?
If it was that,
Yeah.
then it would still have to be 2a dA dx, because I would have derived this and then use the chain rule idea. And I'm gonna show you what we do with this in just a minute.
Is it the same thing when you derive y to get dy or?
Oh, okay. I get it.
Yes.
You do get dy.
So you're always deriving
Oh, okay.
in terms of this variable that we have this equation,
It's
right?
because your d stands for distance, right?
Yes, d is my distance formula. Okay. On this side, how do I have to derive this? This one and this one, these are two separate pieces. I have to use a chain rule. Okay, yes, I'm deriving both of them. So right here, my chain rule, what's the outside function?
2.
This square right here is the outside function. So what do I do with that?
Bring to the front.
I bring it down, I leave the inside alone, and I subtract 1, right, which is the same 1. And then I have to derive the inside. 1/2 y squared minus 1.
1y.
Which is just going to be y. I bring this down, 2 over 2 cancels out, so this is just y. So I'm going to go ahead and just write this y up here with the 2 instead of having it at the back. It's 2y times that. Okay, then I come over here. How do I have to derive this?
Chain rule.
Chain rule. This one's a little simpler. 2 is my outside function, it moves in front, and my inside stays the same. And when I derive the inside, what do I get?
1.
I just get 1, so I don't have to worry about the inside. Okay, or it doesn't change anything.
Wait, when you derive
Oh.
y, you don't get dy?
Huh?
When you derive
This in terms
Because
of
y is essentially the x in this one.
Okay,
Oh my goodness, I'm confused.
the difference between this example and the last example. We have this 2d right here, so my derivative is not actually by itself. Okay? So I get it by itself. I divide by 2d.
Then you can cancel out those 2's.
I can cancel out the 2's. Good. And what is d equal to?
Wait.
What about
Cancel out
that?
both the 2's?
What about that too?
Oh, thank you. D is equal to this. We established that with our equation. And I want things in terms of y.
So are you gonna replace that?
So my derivative of this distance formula is y times 1/2 y squared minus 1 plus y minus 4 over the square root
Oh,
of y squared minus 1 squared plus y minus 4 squared.
Are we gonna make this look pretty?
That's very
I think it's pretty enough.
That's going to be a fun sight.
Let's-
You know what? Dogs don't
No,
judge,
because
so
if it's
adopt
going
a
to-
pet.
Equals 0, all you have to do is at the top equal to 0. You don't really worry about the top.
Wait, I'm looking at you lost me.
How did she lose you? She just put in the thing.
So that's the answer.
No, we got to find the critical number, so when it equals 0, when it's
This is the
top.
derivative. Why do we find the derivative?
So we can find
So
the
we can
zero.
So we can find the critical numbers, and the critical numbers happen when?
When the top
The total
zero
is
and the
fine.
bottom equals
Doesn't
zero.
exist.
When it doesn't exist or when it equals 0.
So we just have to set a both equal.
So I'm going to set the top equal to 0. This was a horrible to do second.
Why?
It's a lot.
Well, it already exposed us to what we're at. My sister comes back tonight, Mr. Brown.
Okay, listen. I'm going to simplify this a little. I'm going to distribute this and combine. Minus y plus y is going to go away. Can you get that?
You what?
I distribute this. Minus y
Oh, yeah.
plus y goes away.
Okay.
And then you'll-
Good? So I just have 1/2 y to the third, because I had to distribute the y there, minus 4. Equals 0.
Urine.
Hey,
Hey.
so I'm solving for y. Y to the third equals 8.
Eight,
Cube root of 8
2.
equals 2.
This is y is equal.
2 equals 4 cubed root of... Whoa! What happened to that?
YZ2.
What happened to the
Y to the power of Z. Y to the power of Z is 2.
What?
Y to the
Last
power
time
of
I
Z.
went
Y to the power of Z.
I multiplied by 2.
Y to the power of
Why?
I cancel it out.
Oh, okay.
To get from the bottom to the top, I didn't see what you did. You did
I
something
simplified this.
Maybe it's come bottom.
I distributed y.
Okay,
That's how I got 1/2 y to the third.
okay.
When I distributed y here, I had minus y plus y. So those canceled out.
Okay.
And then I just had minus 4.
Where'd you get that? How'd you cross out the cubed root of the 8?
I took the cube root of both sides. The cube root of 8 is 2.
No, he hasn't
I had D down there, and D is equal to this. We had, okay, this problem's not finished. What do I do to finish this problem? Find X.
Guys, cheated on squaring.
And we know that X equals 1/2. Stop talking. This came from our equation. Plug stuff in. So 1/2 times 4, X equals 2. So this point 2, 2, what did I just find?
The closest point to 1, 4.
The closest point on that sideways parabola to 1, 4.
We go back to the thing and look for D2 and the rest of
Yep.
it. Just like you build it.
Oh wait, no. Are you?
That's the closest point.
All that.
Here's a real thing.
I told you it's 2, 2.
What if this was like you running through the woods and someone's chasing you,
I tripped.
and this
Is it a bear? Because if it's a bear,
is a highway where people could see you?
I promise you the first thing Miss Kat, I promise you the first thing I'm not gonna do is take out. Please
Let's-
let me find enough so I can clear to the fastest way to the highway right now.
Hang on. We're gonna put some trees
but Mr.
here.
Kraft, you
It's not
realize
like
that the
let me
highway wouldn't
figure
go
out
like
this
that
equation.
in a parabola.
You're in a forest.
I'm gonna have a map. It's gonna be on a grid and everything, guys. And then I'm gonna be able to ask the murderer, hey, remember the chamber?
You're yelling, and there's a car waiting for you right here
That's definitely a
to save you. And it's a police car, so it has red.
plot twist. You're the police cars really the
Look, Kraft, I'm not gonna be waiting for us.
Oh, it's like a little.
So you want to know how to get there quickest,
I'm just gonna run, Miss Kraft, to be honest.
but you're probably gonna run there.
Yes.
But she doesn't even know it's there. You see all those trees that are surrounding her?
She does know because she's a calculus
Bro, I know,
student.
I'm gonna keep running straight, never even hit the highway.
All right.
Oh,
A failing calculus student?
hey, this is the one
What
about the
time do we get
dog.
out of here?
No, we got this. It's ground.
Oh no.
This is like the one we drew out.
The dog, right?
Yeah. Let's go.
This is all about that dog. Remember that dog that knows calculus and runs and then knows when to cross?
Oh, yeah.
Now we
There's
have
a
to
dog
do
knows how
math.
to ride a scooter.
Okay.
Go to the restroom.
Yeah?
I thought math was my favorite subject.
I saw mine, yeah.
Start out with
He
this.
knows how to, a little, like, I know.
But we can't because tomorrow we have to do more optimization.
That's so funny. Like,